All right, so what do we know about similar triangles? What do we know about their angles?
Same.
Yes. And what about their sides?
They're just so many times bigger than the original.
Yes, so we're going to say sides are proportional. If you wrote what you said, that's fine. All right, so number 2A is just like what you all did the last 2 days, where we know an angle and we want to find this, and we know this. So which trig ratio would we use for that side and those two sides and that angle? Sine. So we would say that the sine of 19.5 degrees is equal to the opposite over the hypotenuse, because that's what sine is. And then if the variable is up high, what do? It rhymes. The variable is up high, you're going to multiply. So A is 9 times the sine of 19.5 degrees. And you can just, as long as your calculator is in degree mode, you can type it in like that. You don't have to do the degree symbol. It actually might mess it up if you do. So you would just do 9 sine 19.5. There it is. So if we're rounding, I think it says round to the nearest tenth. What would you say that is? That's just 3. All right, so to help us out throughout this problem, I'm also going to write that the sine of 19.5 degrees is equal to 3 over 9. And what does that 3 over 9 reduce to? Yes. So anytime you have the sine of 19.5 degrees, it's going to be 1/3. And anytime the sine is 1/3, the angle is 19.5 degrees every time. All right, so when we look at letter B, this time we want to figure out this angle. So we want to know the sine of what angle is going to give you 3/9. So what do y'all think? The sine of what angle is 3/9? 19.5.
19.5.
Because we just said it. We just said that. All right, and then anytime that ratio reduces, it's the sine, and it reduces to 1/3, it's still going to be 19.5 for the angle. All right, so let's look at C. So this time we want to find W. It's still opposite and hypotenuse. So the sine of 19.5 degrees is equal to W over 6. What is the sine of 19.5 degrees always going to reduce to? 1/3. So what does W need to be so it reduces to 1/3?
2.
Yep. Because the sine of 19.5 degrees always reduces to 1/3. All right. And so on D, we know the sine of the angle is equal to 2 over 6, which reduces to 1/3. So what's the angle? There you go. All right, and then for A, what is the sine ratio for theta? So that's just saying what is the sine ratio and what is the sine of theta means the exact same thing. So the sine of theta is going to be the opposite over the hypotenuse. What does that reduce to?
1/3.
Well, hold on.
Well, it's 1/3, but
Theta is 19.5. Good. All right, so that's a small portion of what we're going to talk about Monday and today. But the main thing I want you guys to get used to are inverse trig ratios, and they're always going to give you an angle. It's not always going to be 19.5, but so inverse trig ratios always give an angle. So let's draw a right triangle. And I'm going to put theta in the bottom left corner. right, and then my hypotenuse is going to be C. Opposite of theta is going to be A. And adjacent to theta is going to be B. So we talked about inverse functions a long time ago. Like it was probably maybe second 9 weeks, definitely first semester. And inverse functions are always written with an exponent that's -1. So inverse sine is sine to the -1. All right, so what two letters or sides would you divide for the sine of theta?
A and C.
Yeah, so the inverse sine of A over C is going to give you this angle. So the inverse trig function gives you an angle that has that sign that you plugged in. Right? And then the inverse cosine, what would you divide?
A over H.
Oh, adjacent over hypotenuse. Right. So in this case, with A, B, and C, what would it be?
B and C.
Yes. Right. And then the inverse tangent, or the tangent, is always going to be the one that doesn't use the hypotenuse. So you're going to do the good opposite over adjacent, or A over B. Right. Now, a lot of times I know it feels like the math we're doing in here isn't applicable in real life, but this kind of stuff really is. Like my husband builds furniture and things, and he uses the inverse tangent all the time, like all the time. So, all right. So for number 1, we're going to find the measure of the missing angle. And so looking at the angle we want, the one with a question mark and the sides that we have, which trig ratio would you use?
Sine.
Yes. So since we're looking for the angle, we're going to do the inverse sine. And then we're going to divide the opposite by the hypotenuse. And then you're just going to type that in the calculator. So if you don't have a calculator, just grab one real quick just so you can get used to typing this in. So you practiced just doing regular sine yesterday and this morning, or not this morning, and earlier in this lesson. So inverse sine, you hit second and then sine. Did it tell you?
No. Two decimals.
I just did 2 when I did it earlier. And then just do 11 divided by 27, or you could do the fraction button. It's not necessary though. So as long as you're in degrees, which you should be, then that would be the angle that has that sign, 24.04 degrees. All right, so you guys try 2 on your own. So set it up, please, and type it in to find that missing angle. All right, so which inverse function did you use?
Tangent.
Yes. And what'd you get for your angle?
23.19859.
Okay. Yes, you were right. Well, make sure you're in degrees. That's pretty close. Did you do 9 over 21? An inverse tangent? You didn't do inverse tangent? Okay. All right, so let's look at 3. 3 is an application of inverse trig functions, and it's about a hiker. So a hiker is walking up a mountain on a straight trail. So here is the mountain. After walking 8 miles, that's a pretty long hike. she has gained 3 miles of elevation. So elevation is going to be vertical down. Yeah. This is going to be 3 miles. Forgot my M. All right, and then we make a right triangle out of that. And so we want to know what the angle of inclination is, or the angle of elevation. That's a more commonly used term. So looking at that angle and the sides, which trig ratio would you use? Yes. So it is sine a lot. It is not always sine, but it is sine a lot. So we're going to do the inverse sine of the opposite over the hypotenuse. All right, try typing it again. See if your calculator will work it all out. Yeah, I got 22 too.
Oh, that's the angle.
That's the angle. 22.0 degrees is what I wrote down earlier. All right. Some of these are not as straightforward. So number 4 is a little different. So in a right triangle, the hypotenuse is 2.5 times bigger than the side adjacent. So I'm still going to draw a triangle. There are an infinite number of choices we could do for our adjacent and our hypotenuse. But what is the easiest way to represent 2.5 times larger? Like, what would you make the adjacent 1? And then the hypotenuse is going to be 2.5. That's the easiest. That's not the only way, but that's what I would always choose because, All right, and the side adjacent was to angle A. We're not doing sine this time, everybody. What are we going to do? Yeah. So the inverse cosine. Oops, I wrote sine anyway. Oh my goodness, I wrote it twice. The inverse cosine of the adjacent over the hypotenuse should be 66.4 degrees. All right, and then number 5 is one that kind of makes you think. So we want to find an angle x where the sine of x equals the cosine of x.
What, man?
We can do it. So sine of x is opposite over hypotenuse. Cosine of x is adjacent over hypotenuse. So if those two things are equal, what has to be equal?
The hypotenuse.
Well, the hypotenuse will be because it's the same triangle. It's the same x. So the opposite needs to equal the adjacent.
So it's not going to be. It's still going to be a right triangle.
It's definitely going to be a right triangle. It's an isosceles right triangle.
All sides. 2 sides are the same.
2 sides are the same. Hypotenuse obviously can't be the same. It has to be largest. So what two? Well, if the sides are the same, that means the angles are the same. And if this is a right triangle, what do those angles have to be? Good. They have to be 45. Nice job, guys. I knew you could do it. All right.